We are live. This is Math 40, elementary algebra. You can see that I do a little dance here. 1.7, exponents and order of operations. This is very exciting. Things are getting real. We're going to start off with exponents. So this first video is going to be all about exponents. Then in part 2, we will talk about the order of operations. But right now, let's just focus on exponents because they seem like they're not that difficult, but they can be kind of tricksy. So an exponent is used to indicate repeated multiplication. So basically, when you're dealing with an exponent, you're dealing with multiplication. It tells how many times the base is used as a factor. Wow, that sounds like a math teacher wrote it, doesn't it? So what the heck does it mean? If I have a big 4 on the ground and a little 3 floating in the air, this is 4 to the third power, and that is 4 times 4 times 4. So it tells me I have 3 4s multiplied together. And 4 times 4 times 4 happens to be 64. The way we talk about the parts, the 4, the one on the ground is called the base. 3 is the exponent. So far, so good? Woohoo. So how do we refer to these? Well, if I have, say, 2 to the third power, I've got a couple things I can say. I can either say 2 to the third power, or even 2 to the third, which is the slang. You don't have to say the word power. Or I can say something, it's kind of another shorthand, 2 cubed. So 2 cubed, or 2 to the third power, is 2 times 2 times 2, which I happen to know is 8. 2 times 2 is 4, times 2 is 8. Now this one, big 3 with a little floaty 2, is either 3 to the second power or 3 to the second, or much more commonly, 3 squared. And that would be 3 times 3, which is 9. 4 to the fifth power, or 4 to the fifth, is 4 times 4 times 4 times 4 times 4, 5 times. I do not have this memorized, so I'm going to have to use my calculator. Yay! Calculator to the rescue. Okay, so how do we do exponents on my calculator? I'm going to sneak down over here to do on a calculator. So let's go ahead and do 4 to the fifth. On my calculator, I'm going to type in a 4. And then my calculator has a key that looks like a little rooftop. I don't know if you guys can see it in the video. It's right here. But you might also have a key that looks like X to the Y, or even Y to the X. So it'll be different keys, different kinds of calculators. And then 5. And then either an equals or possibly an enter, depending on your calculator. So I'm going to go ahead and type mine in, 4 exponent. Now you'll see I get the little exponent. If you've got a fancier calculator, it may actually push you into the exponent to write the number. Mine is just going to write it straight across. It's less fancy. It's slightly older, like me. Okay, so 4 to the fifth power is 1024. There we go. So far, so good. Awesome. So now let's talk about what to do with fractions. Well, you do exactly the same thing with a fraction. I take the fraction, the 2/3, the rational number, and I write it 3 times because the exponent is 3. Well, you know how multiplication goes with fractions. You just multiply across. So technically, and here we have to be very careful. Technically, you just give out the exponent to the numerator and the denominator. See that? It becomes 2 3 times multiplied times itself, and 3 times multiplied times itself. So it becomes 2 cubed over 3 cubed. Now, this is not the distributive property. It's different. Distributive property looks like this, but it's different. It has pluses and minuses and a whole bunch of shenanigans. So what we call this is either I say you give out the exponent, or if we were in class, I'd refer to it as Oprahing, like after Oprah Winfrey, when she says, okay, everyone look under your desks, or, well, you guys look under your desks, under your seats, everyone gets a car. Well, in this case, everyone gets a cube. Yay! And then everyone's so excited. And everyone in the audience is crying. They always wanted to get cubed. Okay, so 2 cubed is actually 8. Now here's a sneaky thing. 3 cubed is not 9. Although your brain is going to say 3 and 3 and think 9. It's actually 3 times 3 times 3, which is in fact 27. So far, so good? Okay, so what I would like to do, I'm realizing right now, is I could take a piece of paper. I know I'm going off book. This is possibly bad. Could be very exciting. And what I want to do is I want to take just a little tiny bit of time and explain why 4 to the second power is 4 squared. The reason for that is if you take a square, let's pretend that's a square. And in a square, if one side is 4, has length 4, all sides have length 4. And the area, which is the length times the width, is 4 times 4, which in this case equals 16, but it also equals 4 to the second power. So when something is to the second power, it's considered squared because it's like the area of a square. If you have a third power, that is also known as 4 cubed. Now, couple things. I'm going to give you a little bit of art education. I know that's a beautiful square. Let's pretend that's a beautiful square. If you draw 2 squares that have approximately the same size, they're the same size, do them overlapping. See, like that? And then I'm going to do something. I'm going to connect the corresponding vertices. And if this were on a chalkboard or a white, I would make this like a dotted line and this a dotted line, so it's easier for your eyes to see that there's an inside and an outside. Ta-da! I've made a cube. Ooh. If I move these further apart, you can make a box, a longer box. You can do a lot of things. So there you go. Free art lesson. But in a third, so, I didn't write square because it's not obvious. Then I'm going to write cube. This is called a cube. And in a cube, I've got a height and a width and a length. There are 3 dimensions. And of course, if it's a cube, the length of every single side is 4. They're all a bunch of 4s. And here it's not the area, it's the volume is the length times the width times the height. And in this case, that would be 4 times 4 times 4, which of course, yes, equals 64, but that's 4 cubed. So this is why this is cubed and this is squared. Now, 4 to the 4th power, if I could draw a picture of a tesseract, we could say 4 tesseracted, but it never caught on. I've tried. I've really tried hard because I think that would be cool if the 4th power were the tesseract power. But again, no one knows that word, so la la la. Okay, second page, negative bases. Remember the Bat Brothers? Hello. Remember that when you take 2 negative numbers, multiply them together, they become a plus. Okay, leave these guys up here to remind us. If, we have to be very careful, if our bases are negative, so -2 inside parentheses to the second power, That's -2 times -2. There are 2 minuses, so my result is +4. So far, so good. I'm going to go down first, and then I'll come over here. -2 to the third power, or -2 cubed, is -2 times -2 times -2. There are 3 of them, which means these two can be friends and be happy together, but then there's an extra minus that's still sad. So the whole thing ends up being negative, and then 2 times 2 times 2 is 8. So notice that -2, the quantity squared, is +4, but cubed is -8. To the 4th power, what are you going to guess, negative or positive? You're right, I hope, if you said positive. There are 4 of them, and I am regretting that I split the page like this. I thought I wouldn't need all this room, and I clearly do. So you can tell, professional YouTuber, I am not. However, if I've got -2, -2, -2, -2, notice that these two are friends and these two are friends. So this is a lot like 4 times 4, which is 16. We're back to positive. So squaring a negative base is going to give me a positive. Cubing will give me a negative. 4th power, or tesseracting, which I know it's never going to catch on, is a positive. And then here, what if we go to -1 to the 5th power? I'm changing the base a little bit because the numbers were getting kind of big. -1, -1, -1, -1, -1. 1, 2, 3, 4, 5. Now, obviously, the ones all multiplied together give me 1. But what's the sign? Is it positive or negative? You're right. It's negative. Why? Because the 5, the 5th power, is odd. So if it's odd, then we've got a negative. If it's even, it's positive. I'm not sure if you can see that on the video, but if the power is even, the answer is positive. If the power is odd, the answer is negative. Okay, so right off the bat, -1 to the 6th power, right off the bat. Okay, I'll stop. -1 to the 6th power, +1. So far, so good. Okay, so now that you've got the hang of it, now immediately I'm going to throw in a curveball. Apparently, we're all about baseball right now. I think suddenly I talk about bases and bats, and that I'm in baseball land. Notice how this is different from the other problems. No parentheses. So what does this mean? Well, it turns out that exponents, like me, are very nearsighted, and they can only see what happens right next to them. So this 2 only sees the 1. So we get a minus sign and then 2 1s. Notice how before, when the -2 was in parentheses, the whole thing got squared, the whole -2. This time only the 1s get squared. So I end up with still -1. So even though that's even, the answer is odd. It is negative because we didn't include the minus in it. Same thing here. -3 cubed looks like this. The minus hangs out, and the 3 gets cubed. And again, 3 cubed is 27, so we get -27. How about this one? -2 to the 4th power is 1 minus and 4 2s. So I get negative, and then this is 4 times 4 is 16. So take a look at the fact that with parentheses, -2 to the quantity 4th power, the quantity -2 to the 4th power equals +16, but -2 to the 4th with no parentheses is -16. Now, how can I try to trick you? You ready? I'm going to try to trick you now. What if I wrote this? Now, there are parentheses. Notice there are parentheses. But the question is, does the minus sign go to the 4th power? And the answer is no, because notice how the minus sign is outside the parentheses. So this is still going to be negative 16. So I can be sneaky. The parentheses are there, and yet it doesn't go positive. Okay, so again, this is going to probably be a concern for a while. And so ask me, ask tutors. We can give you lots of practice problems. We can help you, go through it a bunch, drill it a bunch until your brain gets that lovely light bulb. Woohoo. Okay, until that, math on. I'll see you guys in the next video on order of operations. Yay!